Hi all, my dear students and GPAT aspirants. Welcome back to my classes. Myself, Dr. Nagaprashant, and in our today's class, we are going to see an interesting topic from pharmaceutical organic chemistry. So, let us see the topic name. The topic which we are going to cover today is free radical substitution reaction of alkanes, which can also be called as halogenation of alkanes. Let me repeat the topic of today again. That is free radical substitution reaction of alkanes, which is also called as halogenation of alkanes. So the contents for today's class are going to be, we are going to start learning from what is a substitution reaction. So let us try to understand what are free radicals, and let us see the mechanism of this particular reaction, which is going to be happening in three steps. That is chain initiation, chain propagation, and then chain termination. These are the three steps that are involved in this particular reaction. So these are the contents what we are going to learn today. Of course, the sequence may be a bit altered because my style of explanation will be a bit different, and you people are going to witness that. Let us see that. The learning objectives of today's class is, after completing this so-called particular video tutorial, the students will be able to define or explain what is a reaction, and we'll be able to explain what is a substitution reaction. We'll be able to explain or define what are free radicals, and the students will be in a position to understand and explain what is the mechanism involved in this particular free radical substitution reaction of alkanes. So let us get into our topic of today's. So as I said, so for today's topic, that is free radical substitution reaction, let us start learning from back. That is, let us try to learn what are alkanes first, and then let us try to understand what is a reaction basically, and then let us try to understand what is a substitution reaction, and then let us try to understand what are free radicals. So after understanding individually everything, then we will be in a position to discuss about what is so-called free radical substitution reaction and how it is going to happen in alkanes in particular. So let us see. Alkanes. Alkanes are also called as hydrocarbons. It is a family of hydrocarbons which are having a general formula of CnH2n plus 2. So for example, if number of carbons is 1, so what we are going to do, 2n, that is 2 into n, here n is equal to 1, so 2 into 1 plus 2, so 2 plus 2, so that's equal to 4. That's why CH4. CH4, that is methane, is the simplest hydrocarbon or else simplest alkane that is ever present in this universe, and followed by ethane, followed by propane, followed by butane, and continues like anything upon increasing chain of carbons. So we do know the naming of alkanes based upon the number of carbons, starting with meth, eth, prop, but, pent, hex, hept, oct, non, dec, which are nothing but, if the carbon total carbons in a hydrocarbon is 1, and if it is alkane, then as number 1 is meth, we call it as methane. 2 means ethane. 3 means propane. 4 means butane. 5 means pentane. 6 means hexane. 7 means heptane. 8 means octane. 9 means nonane. 10 means decane. So this is going to be the structure, and these are all the examples of alkanes, and this is going to be the general formula CnH2n plus 2. And example of the structure by taking ethane as example. So as earlier said, C2H6. So here you can see 2 carbons followed by 6 hydrogens, 1, 2, 3, 4, 5, 6. Total 6 carbon hydrogens. So 2 carbons and 6 hydrogens. So it is C2H6, obviously. So these are alkanes. So ultimately, if you want to talk more about alkanes, alkanes are a family of hydrocarbons which are having only single bonds. We can't find multiple bonds. That's why those are called as anes, alkanes. And all carbons which are present in alkanes will be sp3 hybridized. So you can find only sp3 hybridized carbon atoms in alkanes. So let us see some more information about alkanes in our next slide. So as I said, we can find only sp3 hybridized carbons. So obviously the bond angle between a carbon and an hydrogen, any carbon and an hydrogen, is going to be 109.5 degrees. And we can find only sigma bonds, as that's what I'm trying to mention you, all single bonds. In case if they are double bond, for example, if there is a multiple bond, then one bond will be considered as a sigma bond and the add-on, that is the second bond, is considered as a pi bond. So pi bond will be happening because of side-side overlapping, whereas sigma bond will be formed because of direct overlapping, which you can see like this. Whereas pi bond will be because of side-side overlapping. There is no physical direct contact between the orbitals in case of pi bond. Whereas in case of sigma bond, you can see direct overlapping of this orbitals. So obviously we know that sigma bonds will be more strengthened in comparison with the pi bonds. So that is the reason why alkanes are more stable in hydrocarbon family. Totally, we can see three different type of things in hydrocarbon family, that is alkanes, alkenes, and alkynes. So alkanes will be having only single bonds, whereas alkenes will be having one or multiple double bonds, whereas alkynes will be having either one or more triple bonds. So based upon the types of bonds, whether it is a single bond or double bond or triple bond, based upon these, we are going to decide whether it is an alkane, alkene, or alkyne. So as we are today discussing with only alkenes, so we are going to see only single bonded hydrocarbons. That is, each and every carbon will be sp3 hybridized with a bond angle of 109.5 degrees. We can find only sigma bonds. We can't find any pi bond. So as there is a single bond, we can find rotations between carbon-carbon single bond, which uh, which will result in formation of multiple types of isomers, which are also called as conformers. The isomers which are formed because of rotation between carbon-carbon single bond are called as conformers. So that is what it was mentioned here. And here you can see Sawhorse representation of an hydrocarbon. So this is how Sawhorse representation looks. Of course, multiple types of representations are possible. This is called as Fisher's representation of hydrocarbons. This is a Sawhorse, and so multiple types of representations are possible. Of course, that is not our present topic. That's why we are not going in deep about the types of representations of alkanes. So with this, hope we have got minimum basics of alkanes. What are alkanes and how and what they will have. Yeah, good. And now let us see what is a reaction. Reaction. To be very clear, reaction is nothing but it is a breaking of one bond and formation of another bond. So when a chemical reaction is happening, when one or more chemicals are changed into one more other type of chemical, that is what we'll generally try to define a reaction. That is, reactants will react each other and form a combined product. So that is what we generally try to define a reaction. But as a chemist, if you ask me what is a reaction means, it is nothing but breaking down of an existing bond and formation of a new bond. This is called as a reaction. And while this is happening, while this is happening, if whatever the thing is, it is happening. Okay, while this reaction is occurring, what exactly is happening over there? Depending upon that, reactions can be divided into various types. And our present type is substitution reaction. Substitution reaction means, consider this is A, this is B, this is A, this is B. So A is in bonding with B. A is in bonding with B. So this is A, this is B. A is in bonding with B. So now try to understand that this B is get replaced with a C. B is replaced with a C. So then we can call it as a substitution reaction. For an exact definition, a substitution reaction is defined as a reaction in which an atom or group of atoms will be replaced or substituted by another atom or group of atoms. Then it is called as a substitution reaction. Hope you understood. So what is a reaction? Reaction is an process where reactants will react with each other and form a final product. This is what an exact definition, but as a chemist I am trying to explain you another type of reaction definition, that is breakage of existing bonds and formation of new bonds. Breaking of existing bonds and formation of a new bonds, which is also called as a reaction. And what exactly a substitution reaction means is, it is defined as replacing an atom or group of atoms with another atom or group of atoms. For example, consider a CH3. In CH3, one H is there, a single atom, that is hydrogen. If this hydrogen has been replaced with CH3, it is also considered as an substitution reaction. Here what got replaced? A single atom has been replaced with group of atoms. A single atom has been replaced with group of atoms. So this is what an atom can be replaced with a single atom or else a group of atoms, and again the vice versa, that is a group of atoms can be replaced by a single atom or else a group of atoms, whatever it may happen. So ultimately exactly this substitution and replacement should happen, and then only we can call it as a substitution reaction. And here the example what I'm showing you is combustion. So we know that very clearly. The hydrocarbons will react with oxygen and they try to produce flame. So that is called as a combustion reaction. Here you can see methane reacted with two molecules of oxygen, and it has produced carbon dioxide and two molecules of water, which is called as a combustion reaction. And let us see free radicals now. So until now, what we have completed is we have tried to understand what is alkanes, that is, what are alkanes. We have tried to understand what is a reaction, and we have extended our understanding on reaction to what are substitution reactions. And now we are going to see what are free radicals. So free radicals. If you want to get an understanding about the free radicals, so initially you need to understand a bond cleavage, that is breakage of the bond. Cleavage means it's nothing but uh, breakdown. So a bond can be broken down into two in two different manners. Two different manners. So one type is called as homolytic bond cleavage. Another type is called as heterolytic bond cleavage. So homolytic bond cleavage, homo means equal. Homo means equal. There itself you will be able to understand what exactly it is. So homolytic bond cleavage means a bond will be divided into two equal parts. A bond will be divided into two equal parts. So that is called as homolytic bond cleavage. So before going into further explanation, let us try to see, or let us try to understand what is a bond. A bond, for our present situation, I can tell a bond is nothing but a pair of electrons, that is two electrons. Every bond will have two electrons, whether it may be an ionic bond, whether it may be a covalent bond. In covalent bond, let it be an sigma bond, or else let it be a pi bond. So a bond will have two electrons. If these two electrons has been divided equally, then it's called as homolytic bond cleavage. So that's what you can see here. There are two atoms A and B, and there is a bond between these. That is, there are two electrons in this bond. If this, out of these two electrons, if one electron is being given to A and another electron has been given to B, then it is called as homolytic bond cleavage. So it results in carrying of one electron each. And now when an homolytic bond cleavage is happened when a single electron is being given to one particular atom, then such things are called as free radicals. Such things are called as free radicals. That's what we are able to see here. And the second type of bond cleavage is heterolytic bond cleavage. The same molecule we have taken here, that is A and B. You can see that is A and B here, A and B. There is a bond between A and B, which means there are two electrons in this bond. If both the electrons were given to a single atom, either B or else A, both of them, anything may happen. So if this bond was not broken equally, if it is being broken equally means one electron will be given to one atom, another electron will be given to another atom. If it is not happening, if both the electrons will be given to either A or else B, then it is called as heterolytic bond cleavage. Hetero means different. Hetero means different. Homo means equal. So the bond breakage and distribution of electrons are not happening equally. A difference has been shown over there. And in that situation, it is called as heterolytic bond cleavage. So here you can see as the both bonded pair of electrons were given to B, you can see a minus charge over here. And as A did not got even a single electron, you can see positive charge over here. So this heterolytic bond cleavage generally results in formation of ions. It may be either a cation or else an anion. So when where the negatively charged ion is called as anion and a positively charged ion is called as a cation. In next case, where the both bonded pair of electrons has been given to A instead of giving to B, as in first example, here you can see A has been got a negative charge which is called as anion, and B has got positive charge which is called as a cation. So based upon the type of bond cleavage, we can decide whether we are going to get either free radicals or else ions. So this is what the basic essence of our today's class. What you have to understand exactly is alkanes means hydrocarbons which are having sp3 hybridized carbons and which are having only single bonds. Next thing is a reaction. A reaction is nothing but formation of product upon combustion or upon combination of these reactants. And a substitution reaction is nothing but when an atom or group of atoms has been replaced by another atom or group of atoms. And a free radical is a reactive species which is formed upon homolytic bond cleavage. So today in our reaction, we are going to see free radicals, and these free radicals are going to substitute an atom or group of atoms in our alkanes. So this is called as free radical substitution reaction of alkanes. Let me try to explain this once more. In our today's class, we are going to see the formation of free radicals, and these formed free radicals will be substituting either an atom or group of atoms in alkanes. That's why we are calling this as free radical substitution reaction of alkanes. Yes, hope you have got what is this reaction and what are all the things we are going to see in this reaction of today's. Fine. Now let's go to the next step by seeing few examples and mechanism. So that is what free radical substitution reaction of alkanes and other names. This free radical substitution reaction of alkanes are having some other names like free radical alkane halogenation, free radical chain reaction, halogenation of alkanes. So this particular reaction is having multiple names, all means same. Especially I need to have a 2 minutes of discussion for this particular free radical chain reactions. Why it was said a chain reaction? Because once this free radical substitution reaction got initiated, it won't get closed as easy as possible, because free radicals are highly reactive species. So they will be keep on reacting, keep on reacting, keep on reacting, keep on reacting. So a long chain of hydrocarbons will be formed. That's why it is called as chain reaction. It is a continuous process. It is a continuous process. Of course, while I'm trying to explain the mechanism, you will try to understand what exactly this chain reactions are, what exactly I mean to tell under this chain reaction. Yeah. Now let us try to see the example. So I've given two examples over here. That is chlorination of ethane and propane, through which ethyl chloride and N-propyl chloride were formed. Let us see the first example, ethane, that is C2H6 when reacted with chlorine in presence of H nu, that is light, especially UV light. So it is going to form ethyl chloride and hydrochloric acid. So let us see the second example. Here, why I have shown two examples? Because in case of ethane, wherever the chlorine is going to get attacked, either on this carbon or else on this carbon, we are going to get the same product, that is ethyl chloride. फर्क नहीं पड़ता है, क्योंकि कई किसी तरफ से वो क्लोरीन अटैक करने दो, both are same. So that is the reason why it is called as ethyl chloride. For example, consider this chlorine is not there here. There is a chlorine on this direction. Even then we can call it as, so like for example, if there is Cl, CH2 and CH3, even then it is called as ethyl chloride. Even if it is in this direction, it is called as ethyl chloride. So I have written only one product. In case of propane, it is not the criteria. If a propane was subjected to halogenation in presence of UV light, that is via our free radical substitution reaction mechanism, so this chlorine may get attacked on three carbons, carbon number 1, carbon number 1, carbon number 2, and carbon number 3. Even here, if the chlorine is attacking on carbon number 1 and carbon number 2, both are nothing but same. But if it is attacking on carbon number 2, now there is a chances of getting second product. If the chlorine is got attacked on either carbon number 1 or carbon number 2, 3, either carbon number 1 or carbon number 3, it results in formation of N-propyl chloride. In the another chance, that is if the chlorine is attacking on the middle carbon, that is the second carbon, then we may get isopropyl chloride. So the position of attack is very important in formation of the product. And if you ask me, sir, at which position this chlorine may attack? So exactly, there are very least probabilities to explain this, because as I said earlier, these free radicals are highly reactive species. Free radicals are highly reactive species. They may attack any carbon, but most probably, they will attack the terminal carbons. They will attack the terminal carbons. So the possibility of formation of this particular N-propyl chloride will be more, and formation of this isopropyl chloride will be less. Hope you understood this, and with this basic understanding, let us try to see this mechanism. Mechanism I have tried to explain in two different things. Of course, in both the cases I'm showing you the same mechanism, whereas the first one, the chemistry terms without colors, without anything, whereas the second one you can see a bit colorful. So first let me try to explain a blank and basic mechanism, and then let us try to understand the same with the help of some colorful representations. So let us go to our next slide, that is mechanism. As I said earlier, the mechanism of this free radical substitution reaction can be divided into three steps. The step one is initiation. Step 2 is called as propagation, where we can't stop the reaction. During propagation, it will be keep on propagating. The chain, the length of the chain will be keep on and extending, 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 extending. That is the reason why it is called as propagation. And that is the reason why it is called as free radical chain reaction. Hope you can understand now. And the third step is termination. So let us try to see them in detail. Here you can see the step 1, initiation, step 2, propagation, and step 3, termination. So here, initiation. The name itself is trying to explain us what is initiation. Initiation means the formation of free radicals. Anyhow, if this reaction has to be initiated, we require free radicals. In absence of free radicals, there is no concept of discussing this reaction. So in step 1, it is like formation of free radicals. So that is, the reaction is getting initiated. That's why it is called as initiation step. So in this initiation step, in presence of UV light, a homolytic bond cleavage is going to happen, where equal distribution of electrons will happen, so that we will get two molecules of free radicals. Two molecules of free radicals. And this formed free radical now attacks a hydrocarbon, that is alkane, where one hydrogen will be replaced with a halogen free radical. Hydrogen will be replaced with halogen free radical. That is the reason why this is called as substitution reaction. Here in propagation step, a hydrogen will be replaced by halogen. That's why it is called as halogenation reaction. So you can see this particular free radical, that is halide free radical, is attacking on this particular bond, where this bond will be again divided into two, that is homolytic bond fusion, and the electrons which are present in this particular bond will be equally divided and will be shared to alkyl group and hydrogen equally, and we are going to get an alkyl free radical, and this particular hydrogen free radical will react with halogen free radical, and we will get an hydrogen halide. We will get an hydrogen halide. In second part of propagation step, this so-called formed free radical will react with another halogen, and this halogen also is going to have an homolytic bond fusion, which is going to generate two, which is going to generate two halogen free radicals, out of which one will be reacting with alkyl free radical, which results in formation of alkyl halide, and an halogen free radical, and an halogen free radical. See, after completing these two sub-steps in propagation, I have written 2, 3, 2, 3 continuously. What does it mean? The so-called 2 and 3, 2 and 3, 2 and 3 will be keep on continuing until the no more chances of formation of free radicals is there. until when the chance of formation of free radical is there, it will be keep on continuing. It will keep on continuing. So that's why it is called as propagation. And now let us come to the third step of this particular free radical substitution reactions. That is, you can see in initiation step, molecules has been converted to free radicals, whereas in termination step, free radicals will be converted into molecules. Free radicals will be converted into molecules. Any two free radicals will react and it will form one molecule. You can see here two halogen molecules are reacting two halogen free radicals are reacting to form a halogen molecule. One alkyl free radical and halogen free radical are reacting to form alkyl halide. Two alkyl radicals are trying to react with each other and those are forming another new type of alkane. So that is the difference. In initiation step, molecules will be converted into free radicals. In propagation step, one free radical and a molecule will be reacted to form one more new molecule and a free radical. Here, both will be keep on generating a molecule free radical, a molecule free radical. Whereas in termination step, free radicals will be reacting to form molecules. Hope you can understand this difference now. Now, let us see the same mechanism a bit colorfully for a bit more understanding. Here you can see initiation step where chlorine is going to undergo homolytic bond fission, and this bonded pair of electrons will be equally distributed to both of the chlorines in presence of either high temperature or else H nu, that is light, especially UV light. So you can see formation of chlorine free radicals, and this chlorine free radical is going to react with one methane, that is a hydrocarbon, where this free radical, a single molecule, will react with this particular hydrogen, where this bond between hydrogen and carbon will be cleaved homolytically. One electron from this bond will come to here, so that a new bond will be formed between chlorine and hydrogen. That's what we are seeing here. And we are experiencing the formation of a new methyl free radical. In termination step, this one more chlorine free radical is reacting with methyl free radical to form methyl chloride over here. So this is a bit colorful representation where there is a bond formation between these two, chlorine and hydrogen. So this is what we have seen. If we come to the summary, the free radicals, which are highly reactive intermediates with odd number of electrons, will be formed by homolytic cleavage of covalent bonds. Free radicals can be generated by either heat or irradiation of light, especially UV light, or else in presence of peroxides. Halogenation of alkanes takes place by free radical chain reaction mechanism, and this mechanism involves three steps, that is chain initiation, propagation and termination. And as we already discussed, free radicals will be generated in first step, that is initiation step. And once free radical is generated, a sequence of reactions will be keep on happening, and which is called as propagation. And when any two free radicals are trying to couple each other and to form a molecule, then we call that as a termination step. So this is a summary of our today's class. And learning objectives, the same slide which we have already gone through in our starting of this class, I have replaced. I'm showing to try to show as the same. We have already had discussion about what are reactions, and we have already had a discussion on what are free radicals, and we have gone through the mechanism of free radical substitution reaction. Hope you have understood this particular class. If you have any doubts, I would be grateful to solve them. Please don't forget to text in the chat box. Thank you for patient listening of my today's class. Let us see you in the next class with a new topic. Thank you. Thank you all.